Hi, I'm gonna explain how to solve the quiz 1 from week 2 of physics 2. The problem says like this. A hollow sphere has half of its volume submerged in a liquid with a density of 800 kilograms per meter cubed. It has an inner radius of 8 centimeters and an outer radius of 9 centimeters. What is the mass of the sphere? And then we have to find the density of the sphere. First of all, we're going to draw here the sphere with, it says that it has two different radius. The radius 1, it's the inner radius, it's equal to 8 centimeters. But also it has an outer radius that has 9 centimeters. Now, as it says, this part of the sphere, it's the part that it's filled with mass. And this part inside, it's hollow. So, we also have the density of the liquid equals to 100 kilograms over meter cube. So, and we know that the sphere is halfway submerged. Okay, so only this part is submerged inside the liquid. Okay. Now, as we know, the buoyant force is equal to the weight of displaced fluid. But also we can say that the buoyant force is equal to the weight of the displaced fluid, that is the density of the liquid times the volume of the displaced area times the gravity. Once we know this, we know also that the buoyant force it's equal to the mass times the gravity, because the volume times the density it's equal to the mass. Okay, so once we have this equation, we can see that the gravity, we're going to take these two parts. We can see that the gravity is in both sides, so we cancel it. And now we can say that for obtaining this, that it's my first question, what is the mass of the sphere? We can get the values of these two variables, okay? So the density of the liquid, as we said, it's 800 kilograms per meter cube. So we'll have the 800 kilograms times the volume of the displaced volume. So as we can see, only half of the sphere is inside the water. So this part, it will be half of the volume that we need to calculate the mass. So we have here half, and then we have to write here the formula for locating the volume of a sphere. That is 4/3 P radius cube. But careful, here the radius we are using, it's the radius of the whole sphere, because the volume it's part of the whole sphere, so we have to use the outer radius, that is 9 out radius. Well, I'm gonna write out radius and then I'm gonna substitute it. And all this, that is the density times the volume, will equal to the mass, okay? Once we have those values over there, I'm gonna rewrite that the mass equals to, here we can cancel these two and we'll have only 2 here, so it's 2/3. So the mass, it's equal to 2/3 P times the outer radio cube, the outer radio, it's equal to 9 centimeters, but we are going to use it in meters because the formula says that we have to use it in meters here because of the density. And these times the radio it's cube, like it says here, and this times p. Okay, once we have this, if we calculate it, we'll have the mass of the sphere, it's equal to 1.22 kilograms. Okay, then once we have this, we can solve the second question that says like this: find the density of the sphere. For finding the density of the sphere, we have to consider that the density of the sphere, it's equal to the mass over the volume of the sphere. Okay? Here we can say that easily the mass is 1.22 kilograms. But the volume of the sphere, it's not simple, because we have here that the density of this part of the sphere is different from this part because this one is hollow. So for obtaining only the part that has a density, a plane density, we have to take out the inner part from the outer part. So we'll have here that 4/3 p radio out square, that is the formula of the volume, minus, because we are taking out the inner part of the sphere, the inner part of the sphere. And as we can solve this, we know that we have here we have two constants. So we can say that 1.22 kilograms over 4/3 p, because this is our two constant, times the outer radio, that it's 0.09 cube, minus 0.08 cube meters, because this one is the inner radio. Once we have this equation, we only need to calculate it in our calculator, and we will have that the density of this sphere will be equal to 1.3 times 10 elevated to the cube kilograms per meter cube. And this is how you solve this quiz.